Hi all, this is my second time doing this video. I'm so excited. I messed up the first time it recorded upside down. So here we go. It's going to be that much better because I've already practiced it once. Particle motion, I've put it off up until this point. I'm hoping that with all of your knowledge of integrals and derivatives that this concept won't be difficult. It's just applying what you already know. So let's talk. There's position, there is velocity, and there is velocity, and there's acceleration. I can't spell velocity. I knew that looked weird. Velocity, and then there's acceleration. And position is represented with an S. I don't understand why. Maybe one of you can tell me why. Velocity is a V, acceleration is an A. So, you are given an equation. This is the equation of the position of a particle at a particular time t. You can find it anywhere when you plug in whatever t time you want. This is the picture of that equation. And so the first question is to calculate the velocity of the particle at time t. So position and velocity, their relationship, take the derivative of position and you get velocity. So we'll take the derivative of this guy, v of t is equal to s prime. So that gives us 4t cubed minus 6t squared minus 12t plus 9. That's all they're asking for. Second question is to compute the particle's velocity at these different times. It's really easy. You just sub in the t equals 1, 2, and 4. So we'll do 3 different substitutions. V of at time equals 1. So plugging in 1 for t, we get -5. Now keep in mind your units. We have inches here and seconds here. So inches per second. Velocity at time equals 2. Plugging in 2 for t, we get negative inches per second, which is strange to have a negative velocity, right? We must be going in the other direction. All right, velocity at time equals 4 seconds. So plugging in a 4, this one we've got a positive 121 inches per second. Wow, that's really fast for this particle, it looks like, and it's moving in a positive direction. Now number 3 is asking, when is the particle at rest? So that means that it has to stop and it's going to turn around. So this box over here is the equation, the graph of the equation of velocity. And so we've got resting points on the x-axis. So look at it carefully. It looks like right over here we have a resting point at t equals -1.5. To double check it, plug it in and see if it works. Do we get a 0 when you plug in -1.5 for t? And you do. So that tells us we've got a 0 at -1.5. Now you'll have to employ your Algebra 2 skills to find the others, or you can use your calculator, and I can show you how to do that a little later. You can do some synthetic division to find the rest of the zeros, or the other 2 zeros. Do some synthetic division, and this will give you a quadratic. So you'll have t plus 1.5, and then you've got the rest of your quadratic is 4t squared minus 12t plus 6. So that's just a factored version of your velocity equation. To find the other zeros, plug this guy into a quadratic formula, if you choose not to use your calculator. And so we'll get some funky t's. We've got t equals -1.5 is one of our zeros. We've got 0.63397, so on and so on. And we've got 2.366, so on and so on. So those are our 3 locations where it crosses the x-axis or the particle is at rest. Velocity equals 0. Next, when is the particle moving in the forward or positive direction? So we can go ahead and look at this graph. If I do a little sine line, I've got negative 1.5, 0.634-ish, and 2.366. So below negative 1.5, it's negative. Between negative 1.5, it's positive, and 0.634, it's positive. Then it goes negative, then it goes positive. And this is asking when it is moving forward or in a positive direction. So we've got this interval here and this interval here. So between negative 1.5 and 0.634, and from 2.366 to infinity. Now here's the problem. We cannot go back in time. That's a practical restriction on this problem. So this negative 1.5 business is not going to be part of our answer. Time always starts at 0. We never start at a negative time unless you're launching something and then you have t minus whatever seconds, but we're not doing that. We have a particle moving. So we will start time at 0. And that is when it's moving forward. Okay, number 5 is probably the trickiest of all of these problems. It's asking you to calculate the total distance traveled by the particle after t equals 5 seconds. So we need to know position. Position is S, or this equation here, right? So we want to know how far it's traveled. Now keep in mind, the work we've done so far is going to help us because we know that the particle is turning around when it rests. So these zeros, when the velocity is equal to 0, are helpful to us. We want to know what is the position at time is 0.634. Why don't we want to do time as negative 1.5? Because we can't go back in time. So we are concerned with how far have we gone after 0.634 seconds. Plugging that into your position equation, the original, you've got 2.9461 inches. And then we're also interested in how far have you gone after 2.366 seconds. Plugging that into your position, you get negative 7.4461 inches. This problem is also interested in S of 5. So we plug in the 5 and you've got 270 inches. So here's the tricky part. Let's look at a number line. Here's time is 0, or pardon me, this is the origin. This is where we're starting. This is a distance, so I'll put an S here. And so timer starts moving along at 0.63 seconds. Here's 0.63 seconds. This is where we're located. We're located at 2.9461 inches. Then the particle turns around and the timer keeps going. And then at 2.366 seconds, we've landed here. And we are negative 7.4461 inches from the origin. Then we turn around again, and the timer starts up. And we now go for 5 seconds, and at 5 seconds, we've hit this mark here, and that is 270 inches from the origin. So these are all from the origin or starting point distances. All right, we want to calculate the total distance traveled. So from 0 to 0.634 seconds, we've traveled 2.9-ish. Then we turn around and the timer goes again and we travel back to the origin. So we've traveled another 2.9 inches, but we've kept going 7.4-ish inches. So we're talking about distance, so negative doesn't matter when we're talking about distances. We turn around. We travel back to the origin, so another 7.4 inches, and then we travel another 270 inches from the origin. And we add all of these up and we get about 290.6 8-ish inches. So this one's the hardest because you have to think about that back and forth business. All right, number 6, calculate the acceleration of the particle after 4 seconds. So we've got to go up here and look. To get from velocity to acceleration, you take the derivative again. So acceleration is equal to v prime, which is equal to s double prime. So we're finding the derivative, the second derivative of the original or the first derivative of the velocity. Where did I put, there's velocity. So acceleration equals 12t squared minus 12t minus 12. And they wanted us to determine a of 4. So you plug in 4 into your times. You've got 132 inches per second, so per second squared. When is the speed of the particle constant? So the speed, that means your velocity is constant, right? Are you accelerating or decelerating when your velocity is constant? No, you're doing neither. So your acceleration is going to equal 0. So you go ahead and take your equation of acceleration and set it equal to 0. And we can divide everything by 12. And it looks like we're going to need a quadratic formula for this, but it will happen when time equals negative 0.618 seconds. All right, there you go.